Okay guys, welcome back. We're looking at the example y is equal to negative log x minus 5. Obviously this is a transformation and it's of the form a log x minus h plus k. So a in this case is negative 1, h here is 5, and k here is 0. Okay, so what we're going to do is we are going to, let's look at the shift here. So normally, if this was a log, we would have a graph that went through the points. So if this was just log, one thing to point out, if it says log, the base here is 10. If it's only log, this base is technically 10. Okay, and y? So if you do the log of 1, it's going to equal 0. And the reason for that is because if this was 10 to the x, we know that the domain and range, we have x, y. If we plug 0 into this, we get 1 for your power, or I'm sorry, if we plug 0 for the power, we get 1 for 10 to the 0 is 1. And so we get that, and we know that if we switch the order of the domain and range, we will be looking at a log base 10. And so that will be the same. Now, what does that mean? That means that if we were to graph the blue one, which is the parent graph, log 10, it would look something like the following. Okay, we seen an example on the last video I made, looks something like that. There's an asymptote here at the y-axis. Okay, and it approaches it, and we know that it does not cross that because the domain and range switch, and this does not have any negative values. Now with h being 5, what that means is we're going to shift this vertex 1, 2, 3, 4, 5. The red will be our new point. This asymptote here is going to be shifted 5, so it'll be here as well. Now our parent graph, remember this parent graph in blue is when a is positive. In this case, a is negative, so all that's going to do is that's going to flip this thing upside down, so we'll do it in red. It's going to look something like the following. Now, what is the domain? The domain here, remember for logarithms, is the one that matters, is the one that's limited. The range here is going to be negative infinity to infinity. The domain, however, was changed. Why? Because there's an asymptote here at 5. And it does not cross that. So 5 it approaches, and then it goes off to infinity in this direction. And so our domain and range here are 5 to infinity and negative infinity to infinity. Okay, and just to verify that for you, we'll look at the following. If we look at this, you can see that my graph is very accurate. If I looked at, for instance, this being 6, 1, 2, 3, 4, 5, 6. So my shift did work. It's at 6, 0, which is exactly what Desmos shows us for that graph. And then if I want, I can put in y is equal to, I'm sorry, not y. X is equal to 5. And you can see now the asymptote, which is that purple line, and you can see the green does not cross that. So just to make that point to you. Okay, so now let's get rid of these. And the next one we're going to graph is y is equal to negative e to the x plus 1. So let's get going. Y is equal to negative e to the x plus 1. Don't forget e to the x is just a exponent. Our general form is y is equal to a b to the x minus h plus k. And so here a is negative 1, h is 0, and k is equal to 1. Okay, so let's look at the parent graph, because that's what we always do. We know that if it's e to the x, it does something like this in black. This is the y is equal to e to the x. Now, we know there's an asymptote here at 0. Y is equal to 0, and so this is your parent graph of this in red. Okay. Now let's look at the shifted graph. We have our asymptote at 0, but now it's shifted up 1, so that means we're going to be at 1. We have an asymptote in blue. Okay. Our vertex, well, this was at the point 1, 0. Normally, it would be shifted up 1. Okay, so if we shifted up 1, we'd have a point here. However, we have this negative here, so that's going to, not only is that going to be shifted up 1, it's going to be flipped over. So let's look at that. When I say flipped over, I mean it's going to be on the bottom. So let's think about it. If it was just reflected from this point, it would be put down here at 0, negative 1. And the reason for this, let's look at this. If I plug in 1 to this equation, 0 into this equation, I have negative e to the 0 plus 1, which is negative 1 plus 1, which is negative 1 plus 1, and so this is 0. So there should be a point here at 0, 0. Now you might say, why is that? And I'll do it in blue. Well, let's think about this real quick. This is negative 1 times e to the x. And so e to the x in the order of operations is performed first. So we would do e to the 0, which is 1. And then we'd multiply. We'd do negative 1 times 1. We'd get negative 1. Add it to 1, you get 0. And so if you look at it, if we reflected this point, if we reflected this one, the 1, 0 down to here, we'd have one at 0, negative 1. But then we also need to shift it up 1 unit. So we shift it up, and that's why it ends up in the blue spot. Now, if that point is down there, it's going to do something like the following. Okay. Domain here, we know exponential is negative infinity to infinity. The range here is going to be from positive 1. I was going to say positive 1, but remember we go bottom to top. So the bottommost bottom points here are down at negative infinity. They go up to 1, then don't reach 1. And so that would be our domain and range. And if we wanted to graph it, we could look at y is this. And if I do y equals 1, you can see that it approaches that but does not get to it. And so we believe our graph is correct. I hope this was helpful. Let's look at what else is on here. We have ln of x plus 2. I want you to try it and then use Desmos to check your work. See if you can't get that. Obviously, you'll need to figure out what a, h, and k are, but I think you can do it. Just remember ln is just another log, so you don't have to treat it any special. Other than the fact that it's base e, it's going to look similar to all the other log functions. I hope that you guys can try it and get it done. And if it matches, good. If you need more help, obviously, ask me, email me, talk to me. Thanks, guys.